So this is just another method that we can use to solve the things. Now, when we try and apply this, for example, C, the 2x squared minus 8x plus 5, well, I'm going to do the same thing, where I'm going to start by listing them out. A is equal to 2, B is equal to negative 8, and C is equal to positive 5. Then I'm going to substitute them into my equation. I'm going to say that x is equal to the negative plus or minus the square root of a number squared minus 4 times a number times a number. I'm just using my brackets as placeholders, and then divide by 2 times a number. The first two spots always go to the b, negative 8 and negative 8. A takes the next spot and the bottom, and then the last spot on the top is where C goes. Then I'm going to simplify all three of those parts again. I'm going to simplify this, I'm going to simplify what's inside the radical, and I'm going to simplify the denominator. So now I can state that x is equal to negative 8 is positive 8. Plus or minus negative 8 squared minus 4 times 2 times 5 is going to leave me with 24. All divided by 4. Now at this point, and this is where our radicals become important, at this point I need to be able to simplify my radical. 24 is not a perfect square, but I can simplify the radical. You can do this two ways. You could either say that the square root of 24 is equal to, and then figure out what perfect squares you can divide 24 by. Square root of 4 times square root of 6, which means that root 24 would equal to root 6. Or you can use the factoring tree method. 24 would split up into 2 and 12, 2 and 6, and 2 and 3. I find the pairs, and one of the pairs is going to make it out. Anything that does not have a pair gets left inside. And then I just multiply the things that are not combined. 2 root 2 times 3 is 6. Either way, I get the same answer. So no matter which method I'm using, I'm still going to simplify this and state that this would be the same as 8 plus or minus 2 root 6 over 4. Now I'm looking at the three values that are not inside of the radical once I've simplified. These are my three terms. These are the three things that I'm going to say, is there something I can divide all three of these things by? And in this case, the answer is I can divide all of these things by 2. I can't divide what's inside the radical because I can only divide a radical by a radical, but I can divide all of these by 2. And if I do that, I can simplify this to 4 plus or minus 1 root 6, or just root 6, over 2. This is my simplest form that I can do it in. I can't simplify this any further, so there's my simplest form. The second thing it says is it wants the answers to the nearest hundredth. So I can actually solve the two possibilities here. It's just going to be something that's going to have to be rounded because it's irrational. So when I'm doing this, I'm going to say that one possibility is x is equal to 4 plus root 6 over 2. The other possibility is x is equal to 4 minus root 6 over 2. If I do it to the nearest hundredth, 4 plus root 6 over 2 is going to be 3.22. If I do it to the nearest hundredth for the other one, 4 minus root 6 over 2 is going to be 0.78. And these are the rounded values. And I can double check these on my calculator. I could graph this function and get these same rounded values for the nearest hundredth. My calculator and graphing will not tell me what this simplified version of this is. So for example 3, when it says, explain how you can determine the zeros of a function using the quadratic formula, the answer is the roots of the corresponding equation can be found. Which means that when I replace the y with 0, then with that equation, I would just use that equation and the a, the b, and the c in order to solve the quadratic formula, which is going to give me the same answer as my zeros, because we know that the value of the zeros is the same as the value of the roots, is the same as the value of the x-intercepts. So, in this case, if the function is f of x is equal to 4x squared minus 12x plus 9, then in this case, if I replace the f of x with 0 is equal to 4x squared minus 12x plus 9, then I can see that from this equation, a is equal to 4, b is equal to negative 12, and c is equal to 9. That's what I'm going to substitute into my equation. X is equal to negative bracket bracket plus or minus the square root of a number squared minus 4 times a number times another number, all divided by 2 times a number. In this case, my b goes here and here, my a goes here and here, and my c value goes here. I'm going to simplify and get x is equal to 12 plus or minus the square root of 0. What's inside the radical actually cancels out, divided by 8. And the interesting thing here is the positive square root of 0 is 0. The negative square root of 0 is 0, so there's actually only one possibility. It doesn't matter if it's positive or negative. X is still just going to equal 12 over 8, or 3 over 2. So when everything inside of the radical balances out to 0, there is only one 0 or one x intercept. When I graph this function on the grid, then we can see that it's going to come down, touch the x-intercept at one point, and then shoot back up. and this is going to occur at the point of 3 over 2 and 0, which matches the information that I have. In the second case, I would do the same thing. I'm going to replace the g of x in this case with 0 and say 0 is equal to 2x squared minus 5x plus 10. And here I have a value of 2, a b value of -5, and a c value of 10. So x is equal to negative a number plus or minus the square root of a number squared minus 4 times a number, all divided by 2 times a number. I'm going to substitute the numbers in where they go. I go b, a on the bottom, and the last one on top is c. And when I simplify all these, I'm going to get 5 plus or minus the square root of negative 55, all divided by 4. And then I see a problem because right here I see the square root of negative 55. You can't take the square root of a negative number. Which means there are no zeros. When I graph this out, my function looks something like this. And as we've already seen, you can have no x-intercepts. If there's no x-intercepts, that means that there's going to be no real roots and no zeros. So this is absolutely possible. We can have two solutions. We can have one solution like we saw in the last example, or we can have no solutions, just like we can have two x-intercepts, one x-intercept, or no x-intercepts. So those are my possibilities. Anytime I have two zeros, 1 0, or no zeros, that means either I have two x-intercepts, one x-intercept, or no x-intercept, and the quadratic equation can have two roots, one root, or no roots. This is always possible. So the quadratic formula can be used to determine the roots of a quadratic equation, the zeros of a function, or the x-intercepts of a graph. In each case, it can only be used once it is in general form. It needs to start in the form of ax squared plus bx plus c in order to actually be used.